If you are also looking for professional certified structural engineering services or courses, then don't forget to check link in description of this video.
Hello, today we'll be discussing the basics of structural engineering. A structure engineer must know, or this video can also be helpful for those who are preparing for interviews for structural engineering. So let's start with structural design parameters and basic approach to analysis and design. The structure analysis and design basis. Structure analysis and design is based on providing strength against loads, and the loads include gravitational load, which composes of self-weight of the structure, and superimposed loads. Lateral loads include seismic loads and wind loads. Loading combinations. Structures are designed for any of the following combinations of loading based on the governing combinations: gravitational load, wind load plus gravity load, wind load plus seismic load plus gravity load, and combination of all three kinds of loads. The wind load and seismic load are lateral loads, and the gravity load acts in the downward direction on the structure. Critical loading consideration. Drift due to lateral forces can be ignored if the structure is 13 stories or less. Height to width ratio is 2.5 or less. Otherwise, the following conditions should be considered. This is not recommended in any code, but this is what I am telling from experience working in design office. Wind load is a critical load in tall structures, and areas of severe exposure can be minimized by providing a rigid and braced frame, supports for secondary members, and cladding. Seismic loads are critical in medium to high-rise structures and in areas of moderate to high seismicity, which can be minimized by providing well-tied structure, or you can say braced structure, or different kind of structural systems utilized in the tall structures. Regular geometrical shape, symmetrical, nearly rectangular, etc. Separated by seismic joints of at least 12 to 25 millimeters. Following structural framing systems can be used. Frame system for buildings up to 15 stories. Frame consists of columns, beams, and slab. Dual frame system for buildings of more than 15 stories. Beam, slab, column, shear walls interaction. The figures will be shown shortly. So this is my figure number 2. It shows shear wall, column, beam, and similarly this is a structure which has a lesser height and a higher width. The beams, columns, slab. Beam is referred as a structural member in which the axial load is less than 10 times of AgFc prime, while column is a structural load in which the axial force is greater than AgFc prime divided by 10 according to ACI code. Floor framing systems. Following floor framing systems can be used. Beam slab system. Slab supported on beams and beams supported on columns. Flat plate system, flat slab supported on columns only. Flat slab, slab with drop panels supported on columns only. Flat slab with independent drops. Flat slab with continuous drops. This is a beam slab system in which the columns are first connected to the beam and then connected to the slab. There is no punching shear required in the beam slab system. While this is a flat plate system, it doesn't have any beams as well as any drop panels or column capitals at the intersection of slab and columns. So the punching shear is very critical, and these slabs end up having higher thickness compared to beam slab system. This is a very ideal system for parkings where we need headway or clear headways, while this is a very ideal system for residential floors or office floors with partition walls. This is the flat slab system with column capitals or drop panels. This is called a drop. This is called a continuous drop. When the one-way shear is very high, then we provide continuous drop. Structural design parameters for gravity load. Important parameters for gravity load are self-weight of the structure, live load. Live loads according to UBC 97 is 50 psf for corridors, 80 psf. It depends upon the occupancy of structure. Classrooms 40 psf, hotel rooms 40, wards and private rooms 40, operating rooms 60, and laboratories 60 psf. PSF refers to pound per square feet. This is according to American codes. Floor finishes 30 psf if it is of 2.5 inches, false ceiling AC. These are typical dead loads. Mechanical 150 psf minimum or as per requirement. This is heavy mechanical load. There is another category of heavy mechanical load that refers to 200 or even 400 psf. That can be calculated easily if the mechanical or HVAC equipment floor plan is provided. Partition wall consists of CC blocks 8-inch thick, then the load is 100 psf plus minus and the drywall is 30 psf. Wind speed is 100 miles per hour in most part of Asian countries. Seismic zone as per UBC 97 is classified as 1, 2, 2A, 2B, 3 and 4. Zone 4 is high seismic zone. Peak ground acceleration is 50%. Intensity ranges between 1 to 10 or 9 in some cases, while magnitude is Richter scale. The seismic hazard map looks similar to the one shown on the screen, and for example this seismic hazard map is for Pakistan, and this is the epicenter having maximum magnitude of 7.6 earthquake. The magnitude is classified as one value for the earthquake, while the intensity of earthquake varies as a distance increases with the earth from the earthquake epicenter. Intensity at epicenter is equal to magnitude, while the intensity of earthquake decreases with increase in distance from the epicenter of earthquake. Epicenter is defined as a point from where earthquake is generated. Foundations are designed as per recommendation of the soil investigation report of the following: bearing capacity of soil, groundwater table location, soil strata. On this basis, we select what kind of structure would be having, whether it should be having deep foundation or shallow foundation. The foundation can be consisting of isolated footings for low-rise structures, combined footing for low to medium rise structures, mat or raft footing for medium to high rise structure with poor soil. It is also some cases medium rise structure appropriate. Pile and raft interaction for medium to high rise structures, pile foundation for high rise structures for poor soil conditions. Lightweight structure. To minimize the floor load, lightweight partitions are recommended. Following types of partitions can be used: hollow block for external walls, gypsum cement board for internal walls. Materials of construction. For low to mid-rise structure, concrete having minimum strength of 3000 to 4000 psi, ordinary reinforcing bars, deform bars having strength of yield strength of 60,000 psi. And then we have structural steel buildings ranging from 36 ksi strength to 50 ksi. And then we have high grades of concrete. The high strength material for high rise structure can be greater than 6000 psi. High strength steel can be greater than of 60,000 psi strength. Then we have structural steel. Codes of practice: American Concrete Institute for Concrete, American Institute of Steel Structure for AIS for steel. Then we have American Society of Civil Engineers and National Standards ASCE and ANSI is for loading. We have Uniform Building Load Code for earthquake and wind load, and Uniform Building Code as well referred as ASC 7, which is an upgraded version of UBC and IBC code. Then we have International Building Code IBC for earthquake and wind load. The structural analysis software we have ETABS, SAFE, PCA call, SAP 2000. ETABS is utilized for building analysis and design. SAFE is utilized for slab analysis as well as foundation analysis. PCA call is used for detailed column analysis. SAP 2000 for structural analysis and design of miscellaneous structures such as steel structures. If you are interested in structural engineering, that I would highly recommend you to attend ETABS professional course with a 20-story complete design of building, as well as SAP 2000 professional course which covers the aspects of structure analysis and design using SAP 2000 from basics to advanced level. If you are looking for a career in structural engineering, you must look at the courses published at Udemy. The link to these courses is given in description of this video. Thank you for watching.